Hi, everybody. This is Mr. Folly, and welcome to podcast. Oops, we are at 2.1. We are looking at electrons. So, we're going to talk about off-ball blocks, electron configurations, noble gas configurations. Excited to say electron configuration ions. So, it's a lot. So, I got to be quick. And let's get going. All right. Atoms come with electrons, but it's helpful to think of them as adding electrons one at a time. So, like, I hope you don't think of yourself as being, oh, look, I'm a little kid. Okay, I get a little bigger, now I have a body. Get a little bigger, now I have a leg. Get a little bigger, now I have an arm. Get a little bigger, now I have another arm. It doesn't happen like that. You're kind of born all at once. But it is helpful to think of them being added one at a time. So, when we add these electrons, we need a filling order. Okay, so Aufbau is German, which is the principle for building up. We're going to add electrons to the lowest energy level first. Why low energy? Because that is more stable. So the lower your energy, the more stable you are. So if I was very twitchy, you'd think, oh no, Folly's going to lose his mind on this podcast. But if I'm more stable, then you'd expect the same thing. The periodic table shows this order. Okay, so what happens is you fill it in the order of S, P, D, F. Okay, this is the S block. This is the P block. Whee! Now this little dude right here, he's an S'er as well. This is the D block in green, and this is the F block in blue. Okay? So what happens is you fill in order from left to right. Whee! Okay? Uh-oh. I guess I'll hit next. So how many columns are in the S block? So let's go back and look at that. How many columns are in the S block? It won't let me go back. Isn't that something? So how many columns are in the S block? That would be 2. You count them, okay? How many electrons are in the S block? Well, that would be 2 as well. So 1s2 is going to be the most. 3s2 is different how. So let's take a look. Well, now, okay. 1s2 is the most. So when I look at it, I got to swipe back. I hope. Come on, periodic table. Here we go. So what happens here is when I look at this first box, this is the first row, S block 1. This is the first row, S block 2. This is the second row, so this is going to be 2s1. Second row, 2s2. That says 2s2. It's red on red. Okay. Okay. So 1s2, 2 is the most it can hold, right? So if I say 3s2, how's that different? It is on the third row. How many electrons are in the P, D, and F block? Well, if I count the columns, P has 1, 2, 3, 4, 5, 6 columns. D has 10, and F has 14. Whoops. Okay. P6 is the max, D10 is the max, F14 is the max. Give the electron configuration for carbon. Okay, so I'm looking at the periodic table. Look at your periodic table. On the first row, so I'm looking, okay? Whee! First row, I have these two. 1s, 2. Then I'm going to keep moving across the periodic table. Oh no, I thought I had a periodic table handier than I do. If you don't have your periodic table, you're not looking at your periodic table, you're trying to fail. The second row. On the second row, there's an S block before I get to carbon. Notice carbon is like right here. Second row, I get to carbon. I have to fill both parts of it. Lithium and beryllium are the 2s2. Okay? The next part, boron and carbon are right here. Still the second row, right? Still on row 2. Now we're in the P block. Boron is 1, carbon is 2. That's the ending of it. Write it down. I know this is confusing. We'll get there. But we're going. Okay? So we're going to look at, I'm going to draw a better periodic table that doesn't have all the stuff in it. Shh. So what I'm going to do is go across for row 1, go across for row 2, go across for row 2, go across for row 3, and etc. Okay? So rubidium's way down there. Rubidium's right below potassium. So let's see what we can do here. The first row, 1s2. The second row, 2s2. Then I have to get to the P block. Now I'm in this P block right here. I'm on the second row. I'm in the P block, and there are 6. 1, 2, 3, 4, 5, 6. That's it for that row. Now I'm going to go to the third row right here. There's 2 of them in the third row. 3s, 2. Okay? So this is taking a lot longer because there's a lot more to it. And then after 3s2, we're all the way over on this part down here, which is, I'm moving to see my periodic table more, which is there's aluminum, silicon, phosphorus, etc. That's going to be 3p, p6. Then after 3p6, 3p6 gets me to number 18, argon. After argon comes potassium, and I'm on the fourth row, S2. That's potassium and calcium. Now it gets weird. Whoa! After 4s comes 3d. Okay, so the D blocks are called core electrons because they're actually buried inside of the electron. So we know we're adding on the outside. So notice this is going to be, instead of 4, it's going to be a 3. And there's 10 of them, so it goes 3d10. That gets me all the way to the zinc. Okay, I'm going to continue down here. After 3d, which ends in zinc, I'm back to the fourth level, P block, and 4p, there's 6 of them to get me to krypton. Then I finally get to the fifth level. Rubidium is right here on the fifth level. So it's 5s1. Okay. Now the next one we look at is SM, which has 62, and I'm not going to do that one. Okay. There's a lot of repetition. So a way was developed to show the outer electrons only. Those are the ones that react. Valence is the outer electrons. Okay. Outer electrons are the valence electrons. Valence is typically S and P, and the other blocks are the core. Core notation is synonymous, means the exact same thing as noble gas notation. So if we go back here, rubidium, all I want from rubidium is the outer layer, which is the 5s1. So I want to use a noble gas. The preceding noble gas was number 36. Number 36 is krypton, so I'm going to put krypton in brackets and 5s1, and this is the noble gas notation for rubidium. Okay. If I want to do the noble gas notation for carbon, the preceding noble gas for carbon isn't very helpful, is helium. I put that in brackets, and that takes care of 2 electrons. So now I need 3 through 6. So that's going to be 2s2 and then 2p2. That is the core notation for helium. All right. For the following elements, calcium. So for calcium, I'm just going to do the core notation because I'm running a little late today. So calcium is number 20. The preceding noble gas is argon, which is 18. So I'm just going to put argon in there. And that's 18. Now I need to show number 19 and number 20. Well, potassium and calcium are on the fourth row, S block, 2. Okay. dB, I got to find that on the periodic table. dB is number 105. The preceding noble gas is radon, number 86. So I'm going to put Rn in brackets. And then I got to do 87 and 88. 7s2. 89 to 103 is going to be that bottom layer. That's going to be 5f14. Now the F block moves 2. Remember the D block moved 1. The F block moves 2. So I have 5f14. And then I have 104 and 105. So that's going to be 6d2. Okay? Yikes. We're going to do a bunch of these in classes. Get these down so you can look at them and see. Positive ions lose valence electrons, and negative ions gain valence electrons. So this one's going to lose 3. Aluminum from the periodic table has 13 electrons, so aluminum plus 1 will have 10 electrons. So that means it's going to be the same as neon. So neon is going to be 1s2, 2s2, 2p6. Okay? By the way, this is exactly the same as neon. They are not the same atom, but they have the same electron configuration. Okay? So if I wore the exact same shirt as K-Ed, we're not the exact same person. but we have the same electron configuration. And you would expect we'd be the same. K and I are pretty similar guys. We do the same thing, I guess. I don't know. But we wear the same shirt. Having the same electron configuration means that you are isoelectronic. All right. That's -2. Because it's -2, I'm going to gain 2 electrons. Sulfur on the periodic table has 16. Sulfur minus 2 would be 18. So that's going to be the same as argon. So I'm going to do 1s2, 2s2, 2p6. That took me all the way to neon. Okay. And now I've got to get from 11 to 18. So 11 and 12 are 3s2. And then 13 through 18 are 3p6. I'm sorry about the mystery line there. There's nothing I can really do about it. Okay, so this is isoelectronic with what? Positive ions. So I need something that will end with 18 that's a positive ion. A positive ion will lose 1 or more electron. So that means, oops, if I lose 1 electron, I have 18. That means it's going to be K positive. If I lost 2 electrons, and I have to remember, I'm going to have to end at 18, right? That's my goal. So which one has 20? Well, calcium does, so calcium is +2. Okay? You could put other ones in there, but you get the idea. Bohr says electrons can jump up. This breaks the off-ball principle, but it does happen. So that means that if they jump up, they go out of order. Okay, so first excited state for silicon. Silicon is number 14. So its noble state would be neon. That's the first 10. So I need to do 3s2, 3p2. This is normal. To make it excited, I got to make it jump up. So it's going to be neon in brackets, 3s2, 3p1. What comes after 3p? 4s1. Okay? I hope that makes sense. And I'm going to skip this one just because my time is tight, and so is yours. A few more rules about electrons. Man, these get crazy. Hund's rule of maximum multiplicity. Electrons come in bundles of 2 called orbitals. For us, they look like boxes. Orbitals of equal energy will put 1 electron in each before any orbital gets full. So I call this helping Hund. So that means if I have 2 orbitals and I'm putting electrons in it, the first one is up, the next one goes in the other one, you share it. Another way to look at it is by a real sign at the University of Illinois. You should always choose the urinal that gives you both you and the other person the most buffer. So this works for dudes more than girls, I think. When you go up to a urinal, if you go right here and you're a dude, the next dude does not go here. No, he goes, always leaves that buffer urinal. So it's a sharing thing. No 2 electrons can be in the exact same place at the exact same time. Duh, but know it. The other way of saying this is this holds 2, not 3 or 4 or 5, right? This would be 1 or 2 with a crazy little 1. All right, orbital notation of nitrogen. So nitrogen's electron configuration, I'm going to do this a lot quicker now, is 1s2, 2s2, 2p3. So remember, each orbital holds 2, up, down. 1s2, check. 2s2, up, down. Check. 2p3, up, not up, down, up, up. That's what Hund's rule says. Not up. Oh, don't do that to me. Not up, down, up. Okay? This would be wrong. This is right. Okay. Orbital notation of magnesium. Ah, I thought I'd have it here. So magnesium's electron configuration is 1s2, 2s2, 2p6, 3s2. So I'm going to start right here with 1s, put a box, and there's 1 box because it only holds 2. 2s, I'm going to put a box, up, down. 2p, 3 boxes, because it holds 6, up, 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 down, down, down. 3s, 2, up, down. All right. Half full and full stability. Being full means you are stable. That means you are non-reactive. Being half full means you are pretty stable, which means you're not very reactive. Everything else is not terrible, but I'll get ready for this. So you are either full, You are half full or you are awful. See what I did there? That's funny. So imagine if I'm carrying a 6-pack of Diet Coke, because you know I always have it in there. If I shake it this way and this way, it doesn't bang around very much. Shake it this way and this way, it doesn't bang around very much. But if I have just one in there and I go left and right, right, that's bad. Now what if I am half full? I'm at least okay going this way, right? So that's what we're talking about. So an orbital is really a box? No, it is a cloud. It is a cloud where electrons live. The shape of the s orbital is a sphere, p is a dumbbell, d is complex, f is complexer, and a grade you want to avoid. You'll see pictures of these guys in class. Review, hey, S, P, D, and F. I know the order. Noble is shorter and your friend. Valence electrons are outer, S and P only. Ions are isoelectronic with some other ions and an atom. And orbitals are like boxes, but are really weird. And then this last one, you don't need to know that. Toodles.